session. Naima asked about the DMD in MATLAB. I myself run it in MATLAB. Maybe the version of the code of the MATLAB code, the version of your MATLAB code, and the version of the MATLAB code in this book are different. Is different. Then, because of these differences, some codes cause some errors. Then, it is not because of the code, because the code is correct. I run it. This code. Of course, the DMD, I said this is the reference for DMD book. Okay, page 2 to 15 is explain the DMD. Okay, I run all the code in this chapter, in these pages, and they works. But as I remember, maybe 1 or 2 comments also caused some error in my MATLAB tool. I changed the related comments, and then after that it works. Maybe you also have some problems about other MATLAB codes. And then attention to this. Okay, Naime? No problem. Haider said that no problem. Okay, and now please at first review the content. Where are you in this content? After introduction and set the fundamental of machine learning, we started the computational methods for data analysis. At first, we were familiar with time frequency analysis, and we studied Fourier transform and wavelet. After that, we reviewed some image processing methods, and we analyzed them. After that, we studied singular value decomposition and also PCA, okay, a principal component analysis. After that, we studied ICA, and then after that, we studied dynamic mode decomposition. This chapter is a repeatable knowledge. We attention this information in the previous chapters. Then I didn't explain this chapter. Okay. Besides, we again said something about the recognition and clustering in this chapter, clustering and classification. Okay. Then we studied these chapters and these topics. Now, at this session and maybe next session, we want to review clustering and classification methods. Okay, and then after that, we will start neural networks and deep learning. Okay, till the above topics around in MATLAB, and from here we use Python. We use Python environment to run the codes. Okay. and I haven't uploaded the exercise and the elements because I want to finish this chapter 2, and then after that when we review all the necessary things about the machine learning, basic machine learning, fundamental methods of machine learning, I will upload the exercise, and I will explain in details for you. Yes, of course, I sent the PDF like always. Of course, I uploaded the DMD in the LMS 9. I upload the DMD book. Yeah. Here is the DMD book, and this is a PowerPoint. Okay, and now clustering and classification. The basic and the main reference of this PowerPoint is related to reference B, data-driven science and engineering, and this is also very good reference, very good book. It is similar to C, and the authors are also is the same. Professor Nathan Coates, and here also the author here is Professor Coates too. And Branton is a colleague of Coates. You can search about these two persons in Google Scholar, and you can follow it on YouTube. Their classes, especially Professor Coates, are so amazing, are so interesting. He explains all things in details with patience, and step by step he explains. He explains the topics in reference C and DMD book and the reference B. The author of the DMD book also is Professor Coates. You see, he's from University of Washington. And here you also see that Professor Branton. They are colleagues. Okay, they are famous in this field, in the field of machine learning, matrix decomposition, data decomposition, and DMD. At least please watch one of his course, Professor Coates. It's so wonderful. Okay, then the reference of this session, clustering and classification, is this book, reference B. And then after that, you can search 177. It is related to clustering and classification. The feature of these references of Professor Coates' books is that he explains all things in simple sentences with a very good example, and also all of them has MATLAB code. Then you can run the MATLAB code and change the parameter, the inputs, and see the results. and analyze it. Then it is so good. And these references, his books, are so applicable, are so useful. Okay. At first, about this book, said something about different machine learning methods, about the classification. It said about the supervised, unsupervised, active and offline learning, semi-supervised learning. We said about these keywords before. Then I will not repeat these topics again. Okay. And also have some codes for classification. I myself, any questions? Oh, how much for this semester? Who asked? Intisar, Mr. or Mrs. Intisar, I don't know. I sent and uploaded this content after the part 1. We start the neural network, and then it finished. And attention that this week is week 7. Then it means that the half of your semester finished. You are exactly at the meantime of this semester. Okay, then we finish the half of this content. Okay, besides these references, I myself searched about the PowerPoints. I found some interesting PowerPoints and add the photos and pictures to my PowerPoint too. At first, in the machine learning, we want to process and do the data mining. And data mining is the mix of artificial intelligence, machine learning, pattern recognition, and database system. It contains all of these topics. Okay, and totally, when we want to process data, at first we must do some data pre-processing, some feature selection, dimensionality reduction, normalization, data subsetting. We explained it before. For example, we said about feature selection, we said something about a Fourier transform and wavelet transform. We said something about dimensionality reduction. We said some algorithms like SVD, PCA, ICA, DMD. And we said this normalization, for example, in the chapter of image processing and analysis, we said something about the contrast enhancement like this. Okay. After that, after the data pre-processing, we analyze the data. For example, we said which features are related to which object, or about it is according to the type of data. Maybe it is signals or images or videos. Okay, and then after that, after we apply this on the data, and we do data mining, we usually and totally have some post-processing, like visualization, like pattern interpretation, like filtering patterns, okay, like other things. Totally, I said that the post-processing is related to analyzing the result of data mining after the clustering, like this, classification, like this. Then, totally, we said that data mining task is related to clustering this block. This block is related to clustering or maybe predictive modeling, like DMD, anomaly detection. For example, we have some data related to healthy persons. Some of them is related to, for example, Alzheimer persons. Anomaly detection and association rules. For example, okay, according to the data, we can say that okay, there is a relation between milk and Pampers. Okay, because all the children use both of them. It is an example. Okay, but again, I said that data mining can contain all of these topics, all of these issues. Now, at this moment, at this session, we want to focus on cluster. Okay? Clustering, called unsupervised learning, we said that before. Sometimes called classification by statisticians and sorting by psychologists, and segmentation by people. Okay? The concept of all of them is near to each other. And the organizing data in classes, clustering is that the organizing data into classes that, for example, this class, and this class. Okay? The similarity in each class is high. The similarity in each class is high. Then said that high intra-class similarity. And the similarity between two classes is too low. Then said low interclass. Interclass means between, and intraclass is in one class. Okay, among the data in one class, in one group. Then finally, but after clustering, we want to label the data and say that which data is related to which class, is related to which group. As I said, sometimes we call this classification. Okay? Any questions? I explain in this, yeah? I said that it is better I use in this format that I can see your typing, your messages. At this moment, I think I explained about the data mining. Okay. And one part of the data mining is clustering. Okay, انتصار الويلي, I don't know. انتصار is better for pronouns. Okay, now you have these objects. We want to cluster these objects. Maybe some person that, okay, this is, they are in one class. Maybe another person that, and this is related to other class. Why? Because they are the characters of some this pink characters of some special cartoon, and the blue is another one. Or maybe another person said that, okay, this is man, okay, a man again, and the pink is woman. Okay. Another person may said this clustering, for example, related to the height of each. We can classify this object to many different groups. But how we select this clustering is dependent on the concept of our classification. The concept of our application is select which classification is better. Okay. Then we said that clustering is subjective. As I said, there are female, there are male, and like this. And this special characteristic is Symphons family. Okay. Anyway, according to some similarity, we classified it. For example, said that, okay, there are female here, there are male. The similarity is the sexual features. But in fact, what is similarity? And these photos are so interesting. The quality or state of being similar, likeness, or resemblance, as a similarity of features. And again, said the similarity is hard to define. But we know it when we see it. And totally, the real meaning of similarity is a philosophical question. Yeah? This person, the human, is die. But at the first looking, they are similar. Then, in fact, what is similarity? And what is the quantity of similarity? Okay? Then we explain, we define. For example, we said that, okay, after the feature extraction from different objects, we compare the features, for example, by the distances between them. Or we can say that the similarity like the correlation between the features. Okay. Then we define by mathematical equations, we can define the similarity. Okay. And come back to clustering. From different point of view, we can set that different clustering. Okay, but totally set that we set that partitional algorithm and hierarchical algorithm. We explain this step by step. At first, we want to explain about partitional. We spread some objects, and in this slide, also you can also a more completed diagram about clustering techniques, partitioning methods, hierarchical methods, density-based methods, graph-based methods, model-based clustering. And again, in partitioning methods, we have Cummins algorithm, Commodius algorithm, Commod's, fuzzy Siemens algorithm, and again Commodius, Pam, Clara, and blah blah blah. Okay. In fact, we cannot explain all of them because of our time and other things. But we explain the most common important clustering. At first, we said that Cummins algorithm. The features of partitional clustering is that they are not hierarchical, and each instance is placed in exactly one of core non-overlapping cluster. It means that, okay, when we set this object in the female group, then we don't have this, many times we don't have this object in other groups. And one step of this clustering, we said that, okay, this object is a female. Okay. And since only one set of cluster is output, the user normally has to input the desired number of clusters cut. It means that we at first, or we must to distinguish the number of clusters. Maybe this is the disadvantages of this type of cluster, but it is the features. And before starting the Cummins algorithm, consider this red circle, and then we can measure the distance between the blue circles from the red. You are familiar with this. And for example, here I'll consider this pink circle, and then measure the distance from each blue to pink, and then finally calculate the summation of these distances. For example, here we have 4 blue and 1 red, then we have 4 distance. We finally calculate the summation of these 4 distances. Okay, and now algorithm means decide on a value for K. As I said before, this is the feature of partitioning, clustering. Initialize the K cluster center randomly if necessary. Initialize. Okay. Then decide the class memberships of the n subjects by assigning them to the nearest cluster center. For example, we have this data, this orange data. Then we initialize car1, car2, and car3. Okay. Then decide the class membership of the n subjects by assigning them to the nearest cluster center. For example, said that, okay, this is nearest to car2 comparing with car1. Then this is related to class 2. Okay? Then this is related to class 2. This is related to class 2. This is related, consider here, the distance to car 3 and car 2. Car 3 is near. Then this is related to class 3. Okay? Then decide the class membership of the n subjects by assigning them to the nearest cluster center. Okay. After that, re-estimate the cluster centers by assuming the memberships found above are correct. What is this? Then at first, we estimate initialized center. Step 2, we said that which data is related to which groups, and then we re-estimate. According to this, it means that, okay, we said that this is class 1. Then we calculate again the center of this data, this green data. We re-estimate. We calculate the center of 3. We calculate the center of 2. Okay? Then again, if we come back to the previous slides, we estimate the cluster centers by assuming the memberships found above the curve. If none of the n objects change membership, in the last iteration, exit, otherwise go to 3. It means that after we calculate the center, then we again analyze data. For example, here we said that this is group 1. After we calculate the new centers, we said that, okay, again we calculate the distance, and it seems that it must be related to group 2, not group 1. Okay, then we re-estimate the membership of each data. We repeat it till that the membership of the data doesn't change. Okay, then again here is a step 5. We said that, okay, after repeating this algorithm, we said that, okay, this is again related to group 2, again this is related to group 3. Okay, then at this moment we said that, okay, we can cluster the data and we can classify and cluster the data to 3 groups: 1, 2, and 3. Okay, no questions? Okay. And now the comments on the Cummins method. The cost of computational cost is that T call N. N is the object, K is the cluster, and T is the iteration. Okay, and normally quantity is more or less than N, because N is the number of objects. Often terminates at a local optimum. A global optimum may be found using techniques such as deterministic annealing and generative algorithm. It means that it is user-friendly, and it means that the step constraints of this algorithm is good. Okay, and the weakness: applicable only when min is defined. Okay, applicable only when min is defined. At first step, we initialize the min some means of the cluster. Need to specify K, the number of cluster in advance. They are the weakness, the disadvantages. Unable to handle noisy data and outliers. For example, if we have data here, okay, this is the outlier data. It is hard to label this data is related to this or to this or to this. Okay, and if our data are also noisy, then we have problems. And not suitable to discover a cluster with non-convex shapes. It means that when our data is like this, okay, it's not suitable. In a way, you must attention and you must consider that some methods in each way, in feature extraction, in feature class selection, in clustering, classification, data mining. Maybe one method is very usable for one groups of data. Meanwhile, another algorithm is not good. Okay, then totally we said that it depends on the data, that which clustering, which method is good. Another method is another type of clustering. We have two methods for hierarchical clustering. Set that bottom up or top down. Bottom up means that it's starting with each item in its own cluster. Okay, we consider each item, each object is a cluster. Find the best pair to merge into a new cluster. For example, said that okay, this is female. This all of them is female. But here that okay, for example, they use something, smoking, but these two aren't smoking. Okay? Then find the best pair to merge into a new cluster. Repeat until all clusters are fused together. Finally, we repeat this. Finally, that each object was in each cluster. Okay, and top down is starting with all the data in a single cluster. Consider every possible way to divide the cluster into two. We must find some features, some similarity that using that, by which that we must classify it. Choose the best division and recursively operate on both sides. Completely different from each other. This is bottom up and this is top down. Bottom up from each object, each item we start, but top down, at first we consider all the data. Okay? For example, for the bottom up, we must consider each items. Okay? Then we consider some similarity, some distances. The distance between two subjects is 0. Actually, at this moment, at this slice, we don't know what is the distances, what is the similarity. But said that, okay, imagine, consider we have some measurements, and said that the distances between this green and this red is 8. This green, deep green and light green is 8. Between this and this 7. Between this and again 7. And then after that, according to these measurements, we can decide about the clustering. For example, at first that, okay, these two items are related to each other, these two items, and these two items. And then, after that, we choose the best pairing. See that? Consider all possible merges. And then after that, choose the best. It is the first step. In the second step, according between these two pair items, we paired with another one. At the 3, the new paired again paired with another items. That at the last step we have only one object, one root. Okay, this is from bottom up, starting with each item in its own cluster. Find the best pair to merge into a new cluster. And consider that we only explain and we don't say any mathematical equations. We don't say any things about the dissimilarity or similarity. In the C, it introduced some things about this, and we explain along with some MATLAB codes. can see here, and set that, for example, here. Sorry, here, for example, set that about that. Some typical distances are given as follows: Euclidean distance, a squared, a Euclidean distance, Manhattan distance, maximum distance. Okay, we have many things to calculate the distance, the similarity, but in this PowerPoint we only want the concept of the bottom of this classroom and comments. Then we know how to measure the distance between two objects, but defining the distance between an object and a cluster, or defining the distance between two clusters, is non-obvious. Then we have, for solving this problem, we have single linkage, nearest neighbor. In this method, they are simple also. In this method, the distance between two clusters is determined by distance of the two closest objects, nearest neighbor. Complete linkage is the opposite of single linkage. It is the furthest neighbor. Group average: in this method, the distance between two clusters is calculated as the average distance between all pairs of objects. It means that we calculate the distance between two objects and then finally average it. And what's linkage? In this method, we try to minimize the variance of merged clusters. And here there are some diagrams to explain about these methods. For example, the average linkage. I calculate the distance between 2 and 29, and 6 and 11, then average it. And then this repeat between all of them. And it repeated, that only we achieve to one branch. Okay. And now, then in summary, we can say no need to specify the number of clusters in advance. This is the opposite of Cummings algorithm. In Cummings, at first we have to define and know the number of clusters. But in this method, this do not need. We consider each items and then we continue the methods. These methods nicely onto human for some time. And it said that it is so near to some human decision. Okay. As I said at the first slide, I said that okay, this item is female, this item is female. Then we can put it in one group, and we can say that they are related to each other. And this is the computational cost or time complexity of at least is n2, where n is the number of total objects. Okay. Like any heuristic search algorithm, local optimal problem maybe it is the disadvantages of this. and the interpretations of result is very subjective. Really, it is very subjective. I said it is related to the application of data and the knowledge of a person. And then according to all of them, we can define their equational methods and the quantify their methods. Okay, and it finished. In this chapter of reference B, you can follow this, and we also have honor methods that we will explain in the next sessions. Okay, any questions? No. I hope to understand it nice now, and you get the concept of the clustering in these two methods. Okay, anyway, thanks for your time, for your attention, for your participating in this session, and have good time, and I must say good afternoon.